So on this video, again, which you can find all these notes in your algebra book that we've been writing in all year, or you can print these in the attachment I sent you with the assignments that are going along with this unit. We're going to use graphing to solve the system. So we have two equations. Remember, a system is two equations, but we're going to graph to be able to find that point where both that is common to both equations. So I'm going to make two tables, one for each, just to review graphing because it's been a little bit of time. Remember, we always try to start with our b, our y-intercept, and when I put 0 in this equation, 2/3 times 0, I get 0. Now, when I put in a nice number, since it's a fraction, remember, putting in the denominator is a good idea. So, oops, I already put it wrong. If I do 2/3 times 3, remember the 3's are going to cancel, or you're going to get 6/3. In other words, 2. Either way you think about it, you get 2. Now, I'm going to do the other one in a different color. I'm going to do this guy in blue. So that's standard form. Remember, standard form, it's better to use both the x-intercepts and the y-intercepts. If I put 0 in for x, I get 0 plus y equals -5, so I'm going to get -5. If I put 0 in for y, I get x plus 0 equals -5. If I solve that, I still get -5. So now I'm going to graph both of those. If I graph my red line there, hopefully nobody's colorblind, you can yell at me if I made a bad assumption. And I'm going to graph 3, 2 for my second point. Remember, the other way to do that is think of our b here as 0. Start at b as 0, and my slope is up 1, 2 over 3. You can do that quickly. And then I'm going to try to draw a line. All right, here's my line. And here's another hint to you. I think that it's a pretty good idea to keep up with your slope pattern and go all the way to the edge of your equation, so up 2 over 3 several times until you fill the whole coordinate grid in. So it's easier to tell exactly where the points are because it's hard to draw exact lines. Now in GMM, you won't have that problem, but when you draw by hand, you will. So you're going to want to draw more points on your graph like I just did and add these extra points there. If you don't have graph paper, you're going to want to maybe print some. Otherwise, this is going to be a little bit tricky. If you're having trouble with that, email myself and or Mr. Paspa and we'll help you out. Okay, so to do the blue line, we have to graph 0, -5, and -5, 0. And then I'm going to draw that line. So now I've got both lines there, and you see they intersect in one point. That's the only point that both of the lines have. So that point must be the one point that works in both lines. You can see a solution to a system by finding the point of intersection. That point right there is the point of intersection. And what are the coordinates of those points? Oops, I'm using my highlighter. Let me undo that and use my not highlighter. That point is -3, -2. And if you want to confirm, like we did with guess and check, that that works in both equations, you go for it. You plug it in both equations, it'll work in both. But you can find the solution to a system on a graph by graphing both lines and finding the place where they intersect. So let's do another example. Let's do this one that I just typed in here. And it looks like the same because I use the same template, but let's use our tables down here to make a table. Now, honestly, in GMM, I would simply start at 4 and go up 1 over 3. I would do that repeatedly on a piece of paper, and I would do it the opposite way too until I ran out of grid paper, and then I'd draw my line. If you have to fill in the table, and on GMM it does, you put in 0 for x, you get out 4 for y. That's your y-intercept. Put in 3 because that's the denominator, and then you get 5 because 1/3 times 3 is 1, but then you have to add the 4 on, so you get 5 total right there. Now for the second one, I'm going to draw that line in. That's one line. And for the second one, y equals the opposite of x, or y equals -x, some people like to say. If you put in, say, 0 for x, you get 0 for y. If you put 1 in for x, y is -x, so -1. Okay? And so I'm going to graph 1, -1, 0, 0, And then I see that I have a slope of 1, negative 1 actually. And I'm going to go ahead and graph that. Now you could also just say, hey, it looks like my b is 0 because that's plus 0. And then my slope is, that's a negative 1 right there. So that's a negative 1 over 1, up 1 over 1 to the left, or down 1 to the right, either way you think about it. Now, these two lines intersect, and they intersect in a point right there in the middle. There it is. And the coordinates of that point right there is the solution to the system. It's where both points of both lines have the same point. That's the only point both have in common. That happens to be negative 3, comma 3. It's very easy to mix those around, and it's so frustrating to get it wrong because you mix around, so double check that you put them in the right order before you push enter. So on this one, we're going to do the same thing. So that first equation should be 0, and then 0, and then 1, and then 2. I just picked a 1. You could have picked 4, and then it would be 8, but that would barely fit on your graph. So pick something that's going to fit in your graph. So 0, 0, 1, comma 2. Whoops, I did 2, comma 1, 1, comma 2. And then I see that my slope is up 2 over 1, which is another way to have done that. And I'm going to fill in my whole grid and then draw my line. I'm going to try to draw it by hand this time instead of using my fancy schmancy little line drawer. And then on this other one, if I put in 0, I get negative 2. And if I put in 1, I get 2 times 1 minus 2. That's 0. So I get 0, negative 2. And another way to do this is start at B. And then my slope is up 2 over 1. Up 2 over 1. Up 2. Okay, what is going on here? Up 2 over 1. Something crazy is happening. It's never going to intersect. Never. I hope you remember that there's a special solution to that. That's called parallel lines. These lines are parallel. There is nowhere where they intersect. So there is no solution. There is no point that they both have. There is not a solution to this problem. They do not intersect. There is not a point that both equations share. As a special little side note, every once in a great while, you'll graph a line, and you'll graph another line, and it'll be right on top. I would say that that has a special solution as well. The lines are right on top of each other, so they always intersect. Those are called coincident. They coincide. Coincident lines. And they have infinitely many solutions. That's a Y. Solutions. That's how you abbreviate solutions if you care. So there's another one where sometimes you graph the two lines and they end up being right on top of each other. They intersect everywhere, and they're called coincident, and they have infinitely many intersections.